16? Okay, all AirPods.
15.
All AirPods should be out.
Yes, ma'am.
I need your attention. One of the biggest complaints in math is they don't know what the question's asking. If you don't know the vocab, then that's setting you up to not know what the question's asking. You need to know the vocab. Very rarely will we sit down and have an entire list of vocab. I don't even think it's going to happen at all. But today it is. Because we're hitting those fundamentals of geometry that you have to know in order to be able to do anything the rest of the semester. And it starts with knowing, if I say array, you know what I'm talking about. If I say parallel lines, you know what I'm talking about. I'm going to, so if you notice how these are kind of like puzzles, the way the word is drawn is supposed to help you with the mindset of what the definition is. And then in the box is a notation for it or an example of it. Over here is where we're going to put the definition. So the very first vocab word you need to know is what a point is. Now, I know y'all know what a point is in terms of drawing or writing a sentence and then having a period at the end. That's a point. But the actual definition is that it represents a location and it has no thickness to it, no width, no length. It's a point, okay? If we are talking about a point in a figure, for example, I want you to come over here. Now, don't draw super big because we're going to have a little something next to each one. So kind of try to stay in line with the word. I just want you to draw a very small little triangle. Emphasize one of the corners, which, by the way, is called vertices of the triangle. And then I want you to write a capital letter next to it. So if I was talking about point A, then I would simply use a capital A when I was talking about it. Okay, you don't have to write the word point in front of it. You just write the letter, and it's always capital letters. The next one, line, and then the one after that, segment. Do y'all know the difference between the two? A line.
Oh, it never stops in a segment comes to me.
Yes. A line keeps going in both directions, and a segment has a start, stop. Okay? Line represents an infinite set of points. It has no thickness to it. This word right here is very important. Infinite. That is very important. I need you to write this down, please. Let me give you an example. I'm going to come over here and I'm going to draw a line and I'm going to emphasize 2 points on it. And we're going to call them A and B. If I wanted to talk about that line, I have 2 ways to name it. I can call it line AB or BA. Now, you do go above the letters and you do a notation, which is exactly what a line looks like. You put a line above it, and because it is a line, not a segment, you put arrows on the end of each. Come above it and put arrows on each end. And that's the notation for talking about a line without having to write the word line. crash course on wrapping your mind around how many points are on a line. You don't have to write this. What I'm going to put up here. Okay, so between here and here, let's say that's 0 and 1. What's halfway?
45.
Or let's go with fractions. You'll find out why. Halfway is a half, right? Okay. What's halfway to halfway?
1/4.
1/4. Okay. What is half of that?
1/8.
1/8. You should notice the pattern is that the denominator is doubling because we're cutting it in half every time. So now that I've helped you with the pattern, what's half of that?
1/16.
Okay. What's half of that?
1/30.
1 over 32. What is half of that? 1 over 64. Can we keep going?
Yes.
Mathematically, numerically, can we keep going?
Yes.
Yes. I'll say, what's half that? You double the denominator, you tell me the answer, right? Do you understand that? So, mathematically, is there any limit to this question? No, there's not. That's where the idea of infinite comes in. Now, physically, can I find half of it? No, eventually my finger is going to end up what looks like right on top of the 0. So as far as physically, can you keep cutting it in half? No. Mathematically, can you keep cutting it in half? Yeah, you just keep dividing it by 2, right? So I say that to you. I've lost a few people. I say that to you to see if you can wrap your mind around the fact that if I have on my paper some type of line, and here's a point and there's a point, and I ask you how many points are on that line, don't you dare say 2. It's 2 of them are emphasized, but there's infinite points on the line. Okay? We can't possibly write them all because of the reason I just showed you. All right. Hello. Come on. Okay. Back to this. Segment. That is the same concept as a line, except it has a start and a stop. It is a part of a line between 2 points on that line. It's a portion. I want to text him and say, are y'all getting to them? Because he stops at 1. All right. Here's how you write a segment. Once you come over here, it has a start, has a stop. Let's change the letters. Let's call it C and D. And if you want to talk about that segment without having to write the words line segment, then you would call it CD or DC, and you just draw a segment above it. Notice there are no arrows this time, and that is very important. Okay, a segment has a definite start and stop. A line keeps going. Okay? You name both of them by any 2 points on the line, but if you're naming a segment, it has to be the start point and the stop point of whatever segment you're looking at. Okay? How many points are on a segment?
2. Oh, infinite.
It's infinitely many. It's the exact same argument as the demonstration I just gave you. Even though you cannot see it and you can't physically find all of them, there are infinitely many points in between those 2. That's not us.
Oh, we get done.
12:55.
How did we get to
Fifth block on Wednesday is 12:55. Ray, that is a part of a line that begins at a point and then continues. Part of a line that begins at a point and continues. Make sure you're writing all this down. Writing. So a ray is basically half segment, half line, because it has a definite starting point, but then it carries through a point and then goes to infinity. So here's an example. Draw it with another point right there, and we're going to call it EF. Oh, she just said almost there. Oh, you took a break. I hope y'all can get up there to see him before he stops at 1.
They've been there since 10:30.
11.
I feel like we'll stop
It's
letting
12:30
people
right
like
now.
in line, but they'll let
hope so.
people who are in.
I told him to say that he's being at Disney. All right. Ray. I want you to think of the sun's rays. Where do they start? They start at the sun and then they permeate through space, right? Okay, so it starts somewhere and then it goes to infinity. Thank you. You're my favorite person. Thank you so much. Y'all, come on.
You gotta say,
I even-
beyond.
And beyond.
I even did like a. Anyways.
Gotta say it majestically.
If you are trying to talk about this ray, if you're trying to talk about it without writing the word ray, you have to be careful. So I'm going to put like a bunch of exclamation points because you have to be careful. You only can call this EF, and you have to start at E and then draw a little arrow above F. So be careful how you name a ray. It has to start with the letter that it starts at, and it has to go to the letter that it's passing through. Now I want you to make a note that it is not FE. You cannot do that. That's a big no-no. If you say FE, ray FE, that means it starts at F and passes through E, and that is not the case here. So just make sure you don't confuse those.
We still have 10 more.
I told you this is the only day where we have
Okay.
like a list of vocab. All right, next, plane. A flat 2D surface that extends infinitely far. All right, you like football, then you know what I'm about to talk about. If you don't like football, if you don't know football, go home. Yeah. Then just bear with me. Look at the front of my room as at the rug, okay? Imagine the rug is the end zone. Okay. Imagine the rug is the end zone where it's painted. The teams either. In Tennessee, it's a checkerboard, but anyways, you have the end zone right here, so that means that the playing field is out here, right? Okay, so if the ball crosses the plane, a football player can be diving across, even over in the very corner and hit the pylon. They can be diving across, and if the football is breaking the plane, it's a touchdown.
Roll Tide.
Plane, the
You.
plane, let's
Roll
don't,
Tide.
okay, now everyone's gonna
Go
fail.
Buckeyes.
The plane is, I want you to imagine if you've ever seen like a Mission Impossible movie, like some type of laser flat shield that's right here extending all around, right?
Hello.
So the plane is this flat 2D surface separating the playing field from the end zone. And if they break the plane, that means the football is touching it or is over the plane. Okay? The problem with trying to understand a plane is we are very finite people. We think, oh, this piece of paper is a plane. Well, it is, but you need to imagine that all four directions are continuing on. So don't put limits on it, okay? Just think of it as a flat laser beam extending in every direction. But if you walk around it, like you can see, you know what I mean? You have to really wrap your mind around that. All right, next, collinear.
Oh, we're not gonna write anything?
Nope, there's nothing to write.
Oh, God.
Collinear. This is exactly what it sounds like. Coexisting points on the same line. And you can see in the word collinear, the L's are examples of line segments with 3 points on them. So, now those are segments. Let's draw an actual line, and I want you to put 3 points. So because A, B, and C are on the same line, they are called collinear. Caleb, make sure you're writing this. Now, which brings us to coplanar. That would be I'm gonna make the definition shorter. Three or more objects on the same plane. Three or more objects on the same plane. That's a shorter definition than the one I had. We really don't have a lot of coplanar stuff. That is a vocab word we might say one time. So that's why I was trying to come up with a shorter definition. But you could have points that are coplanar. You could have lines coplanar. You could have line segments that are coplanar. All right, angle. This is important. A figure created by two distinct rays. If you want a shorter definition, you can eliminate distinct, but that is to let you know that they are two different rays coming together. A figure formed by two distinct rays that share a common endpoint, and that is called a vertex. And yes, the order matters when you're naming an angle. The order matters. So we need some room that's going to be right here for us to write. So we want our picture maybe to be up here. So here's one ray. There's one ray. And then here's another ray coming out of the same vertex or endpoint, which makes the angle. Let's emphasize some points on here. And I'm on purpose not going in alphabetical order. You right, Caleb? Thank you. if I want to talk about that angle without picking my hand up and pointing to it, if I want to write it on paper, I have 3 ways to name it. Okay? The first way is if there are only 2 rays coming out of, I call it the elbow of the angle. Think of your arm. Your arm's an angle, right? Your elbow is the vertex. If there are only 2 rays coming out of the vertex, then you can name it by simply the vertex. So you could call it angle A. If you name it by 1 letter, it means you're calling it by the vertex, and you're implying that there is only 1 angle A. If there was, I want you to watch this, but then don't write it. Let's say there was some 3rd ray coming out of it, you cannot call it angle A now. Because there's actually 3 angle A's. There's this one, and then the big one. See the difference? But if I have only 2, it's an arm, right? If I have only 2, then you can call it by the vertex. Or you can go in order as you trace it. So B, A, C, or what's the 3rd one?
CAA.
Think of it, reverse, C, A, B. What letter do you notice is in the middle in both of those? A, and that's because it's the vertex. You absolutely cannot name it ABC because you want it in alphabetical order. If you say angle ABC, I'm going to say there is no angle ABC because that means there's an angle with a B on the elbow and there's not. So know the difference. People get stuff wrong with angles all the time, and it's only because they named it wrong. They actually knew what they were doing, they just named it wrong. Alright, so that's probably one of the most important definitions on here, followed by the next 2 most important. Alright, parallel, perpendicular. Parallel lines. So the definition's short, and then I throw something in there to remind you from Algebra 1. They are lines that lie in the same plane. They never intersect. Then here's the little Algebra 1 add-on, and that's because they have the same slope. If you remember from Algebra 1, parallel lines have the same slope. That's why they're parallel. Their rise over run is the same. Parallel lines never, ever, ever, never, never touch. Ever. I want you to think of railroad tracks. I even might want to suggest writing right here, railroad tracks. If you ever exercise and your instructor says put your feet parallel, they're talking about like railroad tracks. And if they go to say, do a reverse lunge, they don't want you to stick your 1 foot behind the other, because now you're on a tightrope, and that's not good for your knee. They want you to keep your feet on railroad tracks. So imagine parallel lines, railroad tracks, they never touch. If we're talking about parallel lines, without having to write the word, we would say, for instance, line AB, watch this, is parallel to line CD. You do 2 parallel lines, very exaggerated. They almost look like the 2 L's, which is why I'm fixing to highlight this. They look like the L's in the word parallel. They look like the L's in the word parallel. Now, perpendicular. Another very important one. Short definition, little algebra reminder. They are lines that intersect to form right angles. Right angles mean they come together at 90 degrees. That's important. This is also a definition. We're going to talk about it again tomorrow, so you don't have to highlight it on here. They intersect at right angles. They are called perpendicular, and the algebra 1 association is that their slopes are completely opposite. Opposite sign, flipped fraction. Now here's what it looks like if I'm writing it. And I really can't stand when people write the word perpendicular, because I'm going to show you the notation for perpendicular, and it's like it's 2 strokes of your pencil instead of writing the word perpendicular out. Let's say line AB was perpendicular to CD. Here's what it looks like. An upside down capital T. That means perpendicular. And the way to remember that they're intersecting at a right angle is you could draw the little angle there if you wanted to. You don't have to. The notation is upside down capital T. But if you want to help remind yourself that that means, bam, there's a right angle there, then maybe draw the little square to indicate 90 degrees. So you no longer have to write the word perpendicular. You can now just do an upside down capital T. The next one, really not that important. Yeah. You're welcome to slide your desk up here. I had a kid do that last year, and it's fun. It was back there.
Like, I can see everything else, but I can't see anything. Like, I can see the AB, but I can't see anything.
Which part?
Like, on this one, like, AB.
Oh, it's this. Square, and then now it says CD. You're welcome. All right, skew. Skew doesn't come up a lot. I think maybe a skew times. No, just a few times. It's just basically 2 lines that have no relationship. They're not parallel, but they're also not going to intersect. And they're not perpendicular because that means they intersect. The perfect way to wrap your mind around what skew lines look like is this picture. Imagine having a box and you're focusing one line on the bottom front, and then you're focusing another line like on the width on the top. If you extended that blue and red line right there, they would never cross. But they're not parallel either, because they're in totally different planes. So they would be called skew. Circle. This is important. We will have an entire unit on circles, so we will revisit this definition. It is the set of all points equidistant from a given point in a plane, and that given point is called the center. Let me just email it to myself. Poor Ross, he has no teeth. Love this. Yes, absolutely. Check my kid out so he can be a Major League Baseball player.
I wish I was there.
That's his very first time meeting someone of any type of celebrity status. All right, circle. If you are trying to talk about a circle, you see the circle right here where it says C? Put a point right there. And then I want you to put an A. Of course, it's really hard to see. Maybe I should have done a bigger circle.
Can I please get Caleb Lowe to the front office for dismissal, please?
It's on the way.
All right, thank you.
You're welcome. and I want you to put an A in the middle. If I am talking about that circle, all I have to do is, if I'm writing it, I would call it circle. Okay. Hey, you don't have to write the word circle. You just draw a little O, put a dot in the middle, and then you write the capital letter that is the center of the circle. By the way, how many points are on a circle?
You know, infinite.
You don't sound confident.
It's
Nine.
infinite. There's infinite.
9.
Infinitely
Nine.
many. Look,
It's a
if
never.
I was to sit here and draw the points on a circle, right? What's going to happen?
It'll take forever.
I mean, what's going to happen?
Go over. Almost over.
By the time I start drawing so many, it's going to end up looking like one smooth line when it's really not. It's just there's that many points that they merge together. Okay? There's infinitely many points. All right, go to the back.
Oh.
The back is hard to do when your paper is printed in black and white.
Amen.
So if you will please look right here at this picture. By the way, this is orange.
Orange?
Yeah,
Oh.
I don't know why, but this is orange, not yellow. You'll notice not a single thing says, what's the yellow figure? All right, so number 1, we have a word bank, an answer bank. How would you best describe the purple,
So E.
dark purple?
No, that's so cute.
That's an angle.
That is an acute angle.
So can we put that down?
Yes, it is an angle. Now I want you to name it.
Oh, angle.
ED.
No.
EFD.
EFD.
No. DFE.
It's the same. Or,
EFD.
very good. Okay, what about the red geometric shape?
Circle.
It is a circle, and what's the name of it? How do you name the circle?
B.
The
Circle
point
B.
in the middle.
Circle B.
Now, which takes us to the next question. How would you best describe the center of a circle? What object, the vocab word, did we? That is a point. That is point B.
So the pink.
How would you describe the pink shape?
A
And what would
line.
you? It would be a ray,
Array.
It's a ray.
Array FG.
because it's starting here,
Oh.
so it's a ray,
Array
and it's
FG.
going from F through G.
Blue G. So that's a segment. One segment. Well,
What about the blue geometric?
one segment?
That is a, you can just write segment,
So segment BE
or,
or EB.
very good. Be careful when you draw it, don't put arrows. It is a line. Now this one, how many points are emphasized in this picture on that line? It's only one. You cannot name a line by 1 point. You can't do it. So technically, you would need another point on here, or there will be some pictures that we have where there is a lowercase cursive letter floating outside of the line, and that's another way that lines can be named. So it would be line L. Now, why is it lowercase and cursive? I don't know, but it is every time. Orange or what looks like yellow.
There's 3 points, so
That actually is the answer to 8.
So it would be
So go back and tell me there are 2 vocab words you could name orange. One of them we have not said.
It's a collinear. Collinear.
That's the answer. That's the answer to 8.
Oh,
So then it's a complaint.
No. Look, you got an answer box at the top.
oh,
Oh. A skew.
Okay, let me help. From A to C is the same thing as from E to B. It is a segment.
segments.
It's a segment.
Oh,
Okay? From A to C is a segment. From A to B is a segment as well. Not as long, right? Because that segment is in the middle of the circle, passing through the center, there it is. It's also called a diameter. Because it's cutting the circle in half.
And then also the radius.
I think we got
The
to stop
radius
there.
would be the blue one. That would actually be the radius if you wanted to be technical. Or not technical, if you wanted to, is radius up there? Oh, it is. Yeah. No, we're gonna finish. How would you best describe points A, B, and C? Collinear. They coexist on the same line. And then how would you best describe the relationship between green and yellow?
green